a little bit of reference angles, but you didn't really realize it. But reference angles give us another angle to look at. It's a little bit easier to deal with than the angle given. So, for example, if you look, well, this is your guided notes. It's already kind of written down for you. Y'all, that one I just walked around and said, does everybody have this sheet? I know y'all know. What does that mean? Y'all have it? Okay. Oh my gosh. It literally says reference angles. And it's got a little drawing on it like this. This is the reference angle. Do you see the sheet I'm talking about? Got it? Reference angles. We're waiting on everybody to find their sheet. Yeah. Okay. I won't be here Friday.
You have to be here Friday?
Oh, he's coming. He's
Who's coming?
Miss Jenkins.
Robert put his foot down.
Yes, he is.
Okay, reference angles. So here's what happens. I take this theta or I take this angle, right? And this is, I mean, whatever it may be, it's obviously over 90 degrees, right? And I find the angle that's closest to the x-axis that makes an angle. That's my reference angle, and that's what I'm going to use to find my sine and my cosine and things like that. You'll see how we use it in a minute, but first I want to show you how to actually find them. So you have to know where it's located to know what to subtract it from, to know where, Carter, I swear. First quadrant. Is he making fun? Are you making fun of me? Theta, and it's gonna be less. It's gonna be 90 degrees or less because we want it to be something that we can easily work with. So let's look at how we find it. If I had some, remember I need to make the end, whereas if this was theta, I would need to make the terminal side, instead of it being here, I need to make it the x-axis. So one side of your angle is always the x-axis, in other words. You go, Robert, what is your problem? Are you confused? All right, look at number one. Number one's 150 degrees. Let's estimate where 150 degrees is so we can find the reference angle, okay? If I were to draw 150 degrees on there, where would that be? What quadrant would that be in? Quadrant 2, right? Because from here to here is 90. From here to here is how many? 180. So it's between, and you don't have to know exactly where it is. I just need to know that it's between, okay? So this is 150 degrees. And so the reference would be what? 30. How did you do that? So the reference would be 30 degrees. So okay, yeah, to start with. That is correct. Look at you going. So 315 degrees falls where? Okay, what is it, Carter? 315. What's the reference angle? It is 45. Okay, all the way around is 360, right? From here to here is 315, right? But my reference angle is here. So what's left? 45. How about the next one, negative 240? You got to go backwards. So what quadrant are you in? 2. You're in 2. So I went backwards, right? Close. But you don't, because you don't want a negative. Go backwards with that. Not right. Minus 180, right? Because this is my reference angle here. So what do you think it is? It's 60.
Wait, regular 240 minus 180?
Huh?
Regular 240 minus 180?
Yeah. Yeah. It always has to end on the x-axis. And you're not more than 90. Is that what you're saying?
Why couldn't you go the other way and make it one? Like, why is it on the side that you're and not in quadrant?
Negative, so I had to go clockwise. So there's 90, 180, and then up to 240.
All right. Why isn't it past?
Why isn't it
I'm
what?
saying it. Why isn't it going to the right?
Because it's negative.
Come show me. Come show me.
I get it, but
Yeah.
Why is it 120? Clearly you don't get it.
Reference angles are never over
Why
90.
is it not this? Like, why is it not that?
Because that's bigger than 90. You drop down to the x-axis closest to it that's going to keep it under 90. So it's got to be here. Less than 90. Remember, less than 90. How about, why is it what? Okay, so, well, let's think about on the other side, like, why isn't it over here? Or like Robert said, why is it not here? That's more than 90.
What if this right thing up to
minus 180 is 60.
So it can't go onto the y-axis.
Like, it has to hit the x-axis.
Yes, one side has to be the x-axis. I don't know. Y'all are going to have to come up here and show me what you're talking about.
No, I'll show you what the next one.
She's talking about this, like, she's talking about why is it not this? But it's because there's no.
Oh, yes. It can't be on the y-axis. It has to be the x-axis. Yes, thank you. Sorry. Shut up. How about 5 pi over 3? What quadrant, Carter?
Oh, I totally forgot.
That is 180 divided by 3. That's
How do you know this, but you don't know that?
5 pi.
So it's fine.
I don't think.
He's trying so hard right now.
Dude, I know what I'm doing.
Okay, where is it? Which quadrant? Or tell me the degree conversion. All right, how do I go from radians? Radians to degrees is multiplied by 180 over pi.
Then the pi can't.
Close, add another 0 on there.
So we always have to go from radians. Like
300
if you
degrees.
have in radians, you have to go.
I'm fixing to show you radians, and then we're going to do a lot with radians. But This is really just 300 degrees. Agree or disagree? 5 times 180 divided by 3 is 300. Come on.
That's 5
5 times 180
divided by 3. That's 300.
divided by 3. Thank y'all. Yeah. Quadrant 4. Thank you, Lucy. That was... Carter, do you remember when we did degrees and radians? We spent a couple days converting between the two. We took degrees and made them radians. We took radians and he wasn't here. Wasn't here. He was here, but he wasn't here. The reference is 60. That's exactly right, Lucy. That's 300 degrees. So this is my reference, and my reference, the only thing left there to go up would be 60. That was an easy one. How about 7 pi over 6? Oh my gosh. Which is where? Quadrant 3. Here's 210.
Wait, but what is it?
210 degrees.
It'll be 30, yeah. We got it.
Okay, so if I went 180 and I need to get to here, right? How many more degrees is it to get to 210? 30. So the reference is 30.
I disappeared.
Right. Yes. I mean, it doesn't matter as far as pictures. I mean, it matters as far as pictures when you're calculating so you can find it, but if you can calculate it without drawing the picture, that's fine too. Right. All right. Redraw which one? The red one?
Yeah, what are we doing?
Okay, well, do number 6. What quadrant am I in? How do you know? Negative 225. What's your reference angle?
Wait, no. 30, 45.
Now let me kick it up a notch. Because I started, because, depends on where it is. You have to look at it.
Yeah, but like, in the calculator, I already technically added. Like,
yeah, there you go. There you go. Yeah. All right, now, because on these 3, Carter, I started in radians, it's not okay to leave my reference angle in degrees, so I need to switch it back over. I do.
Why?
So what's...
Now you have to multiply it by 180.
no,
Yeah.
pi over 180. Pi
35 over
35 over 180.
I just said that. Multiply that by.
Well, I said that before you.
Which...
I said pi over 180.
I said 35
Yeah, because
All right, which one are we on? Which one are y'all talking about? The 300 degrees? Number 4, what's the radian degrees? What's the radian measure of, what were we? Which is, reduce it all the way. Keep going.
It's 60 over 130.
Yep, this was 60 degrees, so that would be pi over 3.
Pi over 6.
Pi over 6. That's exactly right. That's exactly right. But what?
You multiply this by pi over 1, right?
Yes. Yeah.
Wait, what's the equation?
So to go from radians to degrees is 180 over pi. To go from degrees to radians, it's pi over 180. So we're multiplying these degrees by pi over 180. So what's the reference angle for 60 degrees? This is number 5 on your sheet. Yeah. No. Sorry, this one's 30. 30 degrees is number 5.
Alright, 5 is pi over 6.
Yeah.
30 degrees is what in radians? Pi over 6. All we're doing is taking the answers we got for 4, 5, and 6 and converting them back to radians. So go back to this one. This is number 6.
Pi over 3.
Yeah. Okay, look at this one. Look at number 6. We're all okay on this 45 degrees is the reference angle, right?
Yeah.
Yes? Back row? No, you're not okay with it being 45 degrees?
So you have to do the 2.9 minus 180 because you're trying to get a positive number.
Kinda, he is actually. He kinda is actually. So we're going, because it's negative, we're going backwards. 220, yeah, so to here is 180, so we take that off.
How do we incur -5 divided by 4? Because you gotta do 180 over 5.
He's right.
I just can't like see that on the board. We can do that on the board.
180 over pi. Okay, but that now I just did that to find my reference. Now I need to take my reference angle, which is 45 degrees, and flip it back to radians. So now that is, no, now don't worry about negative reference angles or negative, never negative. So what is that? Pi over what? Pi over 4. We're fixing to derive the unit circle. I'm gonna skip 7 through 10 for right now. Please, I'm gonna show you. All right, here we go. We have a special circle. This is like the big lesson for today. This is the one that will carry you through the rest of your math classes now. Well, no, not that one. All the rest of the real math classes, James. I'm not gonna give you the blank one yet to fill out. We'll get that in a minute. Why? This is all gonna come together in a minute. Wish I had a circle. Shut up. All right. She is very lively. You're not gonna. Okay. I have this circle, and we call this the unit circle, and here's why we call it the unit circle. We call it the unit circle because the radius of this circle is always 1 unit. Okay? That means anywhere you go on here.
She didn't draw it.
You don't even tell him that. I can draw circles really well. There's a guy doing a TikTok doing that, and he just okay. Oh, the best way to do this. The unit circle is derived or comes from special right triangles. Okay, we use special right triangles to form them. So remember whenever we were talking about 45, 45, 90, and 30, 60, 90 triangles, and I told you it was important that you remember them. We would get to it a little bit later. I'm gonna put a couple marks here, a couple radii on my circle. Oh, my circle's not big. It's definitely not drawn to scale. What's the length of each one of those? 1. Why is it 1? That's what the radius is. It doesn't matter where I go to on the circle, the radius is always 1. Do you agree? I told you because I told you. Okay. That good? Okay. I've got 3 different radii drawn here, and I'm going to tell you that the reference angle for each one of these, 30, thank you, 45, and 60, and of course I have 90 degrees here. Now, remember I'm measuring down to the x-axis as I do this. My question to you is, how could I possibly find the x and y coordinates of these points? You're actually not, we're going to use SOHCAHTOA here some. You're exactly right. So I could draw a little line here, right? So let's pull this little triangle out so you can see. Little line. This is now a right triangle. This is 30 degrees and this is 1. Well, do you agree that acrossways this is my x coordinate and up and down this is my y coordinate, right? How am I going to find them though? Do you remember how we do those? Okay, without SOHCAHTOA. There you go. All right, now, this is the short leg, right? And I've got 2 times the short leg goes where? On the hypotenuse. Nice try, but the hypotenuse is always the longest. And the long leg is short leg. That's the special pattern. Remember, we talked about this whenever we started triangles. So you always go from the short leg and you use it to form the other legs. But we don't have the short leg, so we're going to have to go backwards on it a little bit, okay? 1. 2 times the short. So how do I get back to the short leg? Divide it by 2, right? So this has got to be 1/2. Do we agree?
Oh, yes. And then can you use that other formula? It's like,
But then if
What?
that's 1/2, why is it?
then 1/2,
Like,
the square root of
it's
1/2.
not-
That's not 5, that's an S.
Oh,
Short
I-
leg. I'm sorry, that's short leg.
I was saying like,
I didn't want to use X because I used X.
wait, no, but Miss McGee,
I'm sorry.
if they were all 1, then all the short legs would be 1/2.
All the short legs, yes, but whenever I get up to this triangle, then my short leg's on the bottom. But you're right, but they switch spots. But you're absolutely right, and we're fixing to get to that.
So is it square root of 3?
Square root of 3/2, you're exactly right. You could, but you would need to make sure you were able to get an exact value. So with the 1/2, that'd be fine, but on your calculator, if you do it, it's not going to spit out square root of 3/2, right? So you could get this one, and then you could go through and do Pythagorean theorem and get it, sure. Okay, you're not going to ever have to derive it like this. I'm just showing you where it comes from. You'll have to memorize the circle. Some people like to derive it. I like to derive it. I like to show you where it comes from. But, however, if you just are a memorized person and you just want to memorize the whole stinking circle, then that's fine too. Oh my goodness. Over 2. Oh, times short leg, yes. Okay, so I did all that so that you could see what are the coordinates of this point right here. Y'all can do this. Square root of 3 over 2, 1/2. Okay? I didn't put this one on here, but what are the coordinates here? I guess I could go ahead and save us some time. It's not 0, 0, Carter. Right here. What's no?
It's the same as the first one.
0 to 1/2. No, 1, 0, 1.
It's 2.
You're really
0
close.
over 2 radical. It's 0 over
This is 0, 1, yes.
0 over square.
The what's
Well, why are they not? What are they? Why is that?
what's the radius of the circle? Okay.
Yes.
X is your horizontal. This one's 0.
You're like, wait.
Okay.
Wait, when did we get here?
Now let's look at the next. Oh, we didn't do something. Well, 30 degrees is my angle measure. What are the radians here?
What am I reading?
30 degrees. What is that in radians? We've already done it. We just did it. Close. Pi over 6. 30 degrees equals pi over 6. And I'm kind of writing this kind of funky because if you look on your circle,
So then the next one would be
Pi over 4 and then pi over 3.
because I wanted y'all to fill it out later, but it's not. I just, yeah. I know. I'm seeing that. Pi over 2. That's exactly right.
How are y'all getting there?
Y'all are doing this again. Pi over 180. Pi over 180. All right. So this very first line, that's 0 degrees and 0 radians, right? So that's your coordinate. 1, 0. Okay. So then you go up 1.
Write it down so I can just write it down. 45.
All right. I'm gonna pull this quadrant one out over here. All right, so here I have 0 degrees, 0 radians, and this coordinate is 1, 0, right?
Nope.
On the axis is 0 degrees, and then you move up to 30 degrees, right? So this one,
Why don't we have a far apart?
0 degrees is the bottom one.
right, I just ran out, I was just showing you that 30 degrees is this angle right here. 45 degrees is this angle, 60 degrees is this angle, and 90 is this whole quarter. So if you don't go anywhere, you're 0 degrees. What? Yes, yes.
Mm-hmm.
This is always this, yes.
0, 1 for 90.
Yeah. Yes.
Wait, so
You have to know the first quadrant. You can derive all the rest of them after you get the first quadrant. Finding it based on what you know. No, that's a guess. Okay. We said that these coordinates, this coordinate right here was
pi over 6. Oh, square root of 3 over 2.
there you go.
And then what was it?
1/2. Okay. I'm moving on.
That I
Like you can write this on this with marker. I have it. My calculus kids have a laminated version of it. It's, you want a laminated version?
Yeah, actually, yeah, that would be great.
So
I see what I can do.
So 30 times 180 divided by what?
What?
How are you getting like 5, 6, 5, 4, 5?
Because you divide by 180 and then
It's 180 over pi, right?
Pi over 180.
it's 5
Oh,
180.
pi.
We divide it by 180. And throw pi on top. Okay. Again, you don't have to do this every single time, but I find it very helpful to know where it comes from and how to find it. I could not, in good faith, teach a unit circle without showing you the triangles that make up the circle, but I'll only do it for quadrant 1. All right, let's look at the second triangle. So this one this time is a right triangle. The hypotenuse on all of these is 1, right? But this one instead has a 45-degree angle here. And I need the x and the y coordinates, right? This is going to be my x, this is going to be my y. Is it? Are you sure? 45.
Wait, no, that's just 45. It's one of the special ones, isn't it?
It's a special. But I go from the leg to the hypotenuse, and how do I do that? Leg, leg. How do you get to the hypotenuse?
0.25.
What were you going to say?
How is it not 1/4?
Okay, so even if you did Pythagorean theorem, 2 times leg squared equals hypotenuse squared, right? L squared plus L squared equals H squared. That's not going to work. Yeah, you can. L squared equals... If I do L squared plus L squared equals H squared. You know the hypotenuse, so I need to go here and do this, right? So how do you go? What's the? I'm trying to get y'all to. You're supposed to have it memorized, but I'm trying to get you to show it. The hypotenuse is 1 on this, but what's the pattern for a 45, 45, 90 triangle?
Are you asking if you don't know yet?
I'm asking because I want you to know. I know what it is. Do you want me just to tell you? It's the square root of 2 times a leg. Because somebody said, how do you know, or somebody said Pythagorean theorem, and I was like, well, actually, you could get there from that. Okay, but it doesn't matter. It doesn't matter. It doesn't matter. Okay, so if I multiply by square root of 2 to get to the hypotenuse, how do I get from the hypotenuse to the leg? You divide, right? So if I do 1 divided by the square root of 2, I can't have a square root in the bottom. So you put in it's just square root 2 over 2. And because it's a 45, 45, 90, it's isosceles. So the other side is square root of 2 over 2. So what are the coordinates here at pi over 4? The hard work is over because it's 6.
No, they kind of do it. Yeah.
Okay, so to get from a leg to the hypotenuse of a 45, 45, 90 triangle, you multiply by the square root of 2. But on the triangle, I'm going from the hypotenuse to the leg. So I'm going backwards, so I have to divide instead of multiplying. So like if I had a 45, 45, 90 triangle, and I told you that this was 7, I told you to find all the other sides. But you know that these are the same, right? And this side would be 7 times the square root of 2. But if I had a triangle that I told you this was 7, again 45, 45, 90, how would you get to the legs this time? To go from here to here, I multiply, but if I want to go backwards and undo that, I would need to divide by the square root of 2.
7 times square root of 2.
No, yeah, so times first.
If you are lost, do not fret. Carter, don't fret. Because you can just memorize the circle too. But it helps you to know. Okay, but you'll see the cool thing that comes with the circle in just a second. But let's finish with the circle here. This is the same triangle. Somebody said it. I don't remember if it was Mac or James or somebody. This is the same triangle, but it's flipped around. Now the short leg is where the long leg was and vice versa. So my coordinates are going to be exactly the same. They're just going to be flipped. So this is just going to be 1/2 square root of 3 over 2. If only I was done. I have 3 more quadrants to go. But, no. But here's the nice thing about it. We're just going to use the properties of a circle and it being symmetric and everything the same to derive the rest, or to fill out the rest of it.
Just the same as split.
The coordinates are the same, but you've got to think about signs change. Signs change, and I got to think about my angles, okay? Because my 30, my 45, and my 60 are going to be my reference angles, but I'm going to move them to other quadrants as well. So as I move around my circle, okay, so now we're in quadrant 2. So this was how many degrees? I've got, it's symmetric, so the same thing is between all of them, right? So I go from 90 degrees to what to get here? Another 30, so 120. So now I'm at 120, and I find it easiest if you do the degrees, and then we'll come back and convert to radians. What's next? No. 135. Why? From 30 to 45, there's 15 in between, right? So what is this one? All right, let's keep going around the circle while we're on a roll here. As I move around, again, 30. So remember, 30, 15, 15, 30, right? That's what I'm going. 30, 15, 15, 30. 210. 30, 15, 15, 30. Keep going. 300.
30.
Radians. Do you want me just to give them to you, or do you want to calculate them?
So that'd be 3.
No.
Well, I think
For the coordinates, yes. Yes, for the coordinates, yes. All right, 120, what's the radian? 2 pi over 3. You see them on what paper?
right there. Wait, what?
Dang it!
He got it.
No, it's not. This is actually 3 pi over 4. Gosh, James, you did that so fast. Oh, that's not pi over 2. That's pi. That's a whole pi. Pi over 180. I'll show you a little trick to memorizing it too. I'll show you a little video tomorrow. Tell us how you really feel. It's quick. It's like a little trick on how to get the first quadrant. No, it's not like that. No wonder you didn't understand. All right, keep going. 7 pi over 6. I can't believe I gave them to you. Great,
Well, I
Dave.
didn't know that they were on the back until now.
I didn't know that either.
Yes, they are. That's how we're getting them so fast.
5 pi over 3. All right, let's fill in the coordinates. I didn't finish this one. Coordinates are easy because you simply remember how we were looking is what's positive, what's negative, where I am, cosine, sine, and sine. The unit circle is very handy because we're gonna use it to find all the trig functions of these angles, and then I'll be done. All right, so here I'm at the same place, but my x is negative, right? Because I go over in quadrant 2, which means x is negative, y stays positive. Negative 1/2 square root of 3 over 2. So everything's the same, but all the negatives, all the x's become negative. Where you put what? I love the unit circle. Deriving it. What? All right, everybody negative in quadrant 3. So negative root 3 over 2, negative 1/2, negative root 2 over 2, root 2 over 2. Negative. Yep, quadrant 3, x and y are both negative. And then in quadrant 4, x is positive and y is negative. Does what say what? $270. Yeah, if you have good eyes, it's written real little on your. Oh no, it's not. Not real. Except for the coordinates, which are the most important. Well, I wouldn't say the most important, but they're pretty important. The over 4s will be your favorite. So why do we need this? What does it do? It is a reference. So if you think about this being triangles, look at my triangle that I pulled out right here. If theta is 30 degrees, what is the sine of theta? So what's the sine of 30 degrees? Sine is what? Opposite over hypotenuse, which is 1, so it's just 1/2. What's the cosine of 30? Adjacent? So square root of 3 over 2 over 1, which is just square. So in fact, and look at where I was on this circle. This is the cool part. So if you've zoned out for everything else, that's exactly right. On your unit circle, the cosine of theta, wherever you are, whether you are in radians or degrees, is your x coordinate at that value. All right, the cosine is the x coordinate. The sine is your y coordinate. So if you have this in hand, I could look at you, and this is why you have to have it memorized, because before we're done with it, you'll have a timed quick quiz where you'll have to remember. I know, but not yet, not yet. Let's say I asked you, what is the cosine of 240 degrees? Cosine of 240.
Did I get it wrong?
No, you got it right. I have it labeled wrong. I didn't have that. Cosine of is x, right? So I go to 240 and I go cosine is x, so it's negative 1/2. Because I said, what's the cosine of 240? What's the sine of 3 pi over 4?
Oh, I forgot to write down the rate. Oh, dang it.
You find this on the unit circle, and then you'd take the y value there. There's only one 3 pi over 4.
3 pi over 4 is 135 degrees, which is, so the sine is 2 over 2.
Square 2 over 2. What?
Oh, wait, the y.
I'm on number 11 on your sheet. What's the sine of 135? That's right. Sine of 135, so I go to 135, square root of 2 over 2. Right? All right, this one's a little bit harder. What's the secant of 180 degrees? Secant's 1 over cosine, right? So what's the cosine of 180 degrees? Close. Negative 1. What's the cosine at 180 degrees? Go to 180 degrees. Cosine is x, so it's negative 1. Negative 1. 1 divided by negative 1 is negative 1. Skip 13 because I haven't told you about tangent, but I'm fixing to. That was number 12. Well, the guided notes. The guided notes.
I didn't write down any.
That's okay. That's okay. 11 square root of 2 over 2. Skip down to number 14. Skip the cotangent because I hadn't quite told you tangent yet. Cosecant of 120. Close. Okay, cosecant is 1 over what? Sine. So whatever sine is there, I'm going to flip it over. So go to 120. All right. Sine of 120 is square root of 3 over 2, right? So the cosecant of 120, is 2 over square root of 3. I can't have a radical on the bottom. How about 16? Cosine of negative 150. This time, look where 150 is and go that much in the opposite direction, right? So 150, if I loop around, is in quadrant 2. But I got to go backwards that much. So I'm right here. So the cosine is negative root 3 over 2. All right. Because it says cosine, look at number 16. Cosine of negative 150. Cosine negative 150. So if I went positive 150, I end up 1 click above the x-axis, right? So I'm going to do the opposite direction and stop 1 click before the x-axis. What's the cosine there? Negative square root of 3 over 2. but don't worry about it. That was just getting you to, if you look, what's the sine of theta? That's y. The cosine of theta is x. Okay, which brings me to tangent. I need to show you tangent. I know this is a lot. Stay with me. I know. Caroline is about to die back there.
Alright, this is probably gonna go.
Okay, thank you. Yeah. The cosine of 3 pi over 4, so where is 3 pi over 4? Yeah, negative square root 2 over 2. 3 pi, here's 3 pi over 4, right? At 135. What's the cosine? Negative square root 2 over 2. But, well, I'm fixing to show you. So cosine is x, sine is y. Y'all ready for tangent? And we're going to fill in the tangent values around the circle, and then we'll be done. Tangent, I would show y'all with the triangle and why this works, with opposite over adjacent and everything else, but I'm just going to tell you what it is at this point. It's y divided by x. We're gonna go through and write it on our circle right now. We're gonna go through and figure out, because again, if you find the first quadrant, everything else. All right, so look, if I do 1/2, 1/2, oh my gosh. No, it's not. Don't say that. Don't say that. Okay. Okay, look. If I do y divided by x, and I'm just, so on the unit circle that we have in calculus, I have them, all the tangent values boxed off around. So if you want to box off to the side like that, so that you have them to reference as we go. Again, there is a lot of stuff. It is a lot. Everybody's confused when you first see it. It's a lot. It's a lot of stuff. But the more you work with it, you find out it's not really that bad. Okay. And there's a pattern to it because look at the fractions here. This is right up your alley, Carter. 3, 2, 1, 3, 2, 1. They're all over 2.
Oh my God. All right.
I didn't even realize that.
Yeah.
And then there's I can't remember
And they're all over 2.
I can't remember the pattern.
They are all over.
Yeah. I can't remember the pattern to the radians, but that's what I said. There's memory. I'm gonna show you a video on some memorization tricks. But today I wanted you to know where it came from, that I wasn't just throwing random things out at you, that it was really a mathematical tool that we use. Okay, tangent, y over x, right? What is the tangent? What is the tangent at 0? 0 divided by 1, which is 0. Not undefined, but 0.
0 is over 1.
So there's my tangent value at 0. Let's go to 30 degrees, which is the same thing as pi over 6. By the way, most of your, probably after your homework tonight, most things will be in radians and not degrees anymore. We start transitioning. I know. Okay. If I do y divided by x, right? So I've got 1/2 divided by square root of 3 over 2. So flip, flip, so I'm going to do 1/2 times 2 over the square root of 3. Right. Again, you won't have to do this every time unless you just can't memorize it, which is fine too. I always had to derive the tangent values. They all have a tangent. So the tangent of pi over 6 is root 3 over 3. Yes. And again, here, these are just flipped, right? So what do you think the tangent value here would be? at pi over
It'd be the
3.
same thing. It would be radical over 3.
Keep simplifying.
Same thing as the first one.
Just square root of 3.
We cannot do homework.
Y'all, this was supposed to be with the lesson we did Thursday. Okay, so why, Lucy? Why can't you do that? It's undefined. You can't divide by 0. So up here we're undefined, and whenever we get to these graphs, you'll see why. You'll see what that looks like. So, no, backwards. 1 over 0 is undefined. 0 over 1 is 0.
It's already 1.0.
I'm almost done. I'm almost done. Y'all are killing me. Oh my gosh. We actually finally got to pre-cal and y'all are dying on me here. Okay. This unit. Unit we're on right now. Well, what we can get through. Yeah, we don't have much left. But I mean, I couldn't teach you all this without having the prior. I would have probably, well, yeah, but it's okay. It's okay.
Further?
I mean, how much further did you expect us to be?
I figured we'd be about 2 units past where we are right now.
Oh, no.
When the next class will get there.
Thanks, Carolina. It's okay though. It's okay.
You'll be there in like 4 or 5 weeks. You'll be teaching them actual calculus.
The good thing about calculus is, though, I can teach you calculus without you have even had pre-cal. I've done it.
What?
It's way easier if you've had it, but I can do it without it. What?
You already know that none of us are taking it. I might take it. I might take it.
See, y'all, please, you should. You should. You definitely should. First semester is kind of hard, but then past that is.
This is easier than like going to college.
If you put forth the effort, I have never, no, seriously though. No, effort, like, you pay attention. What you're doing here is plenty effort enough for you to have passed the AP exam. Oh no, I'm talking about passing the exam. The grades are great. As long as you do your work, everybody's got it. I don't want to talk about calculus because I love it. Okay. What do you think the tangent value is here? If this one coordinates with this one.
Oh, I thought it would be negative.
Negative square root of 3. Make sure all your values on your circle are accurate because that's how you're going to get the right answers on your homework and stuff. How about here? It literally, thank you, Caroline. It really doesn't take long when you have the circle filled out whenever you find out what the pattern is you're looking for. And then it's negative square root of 3 over 3.
You can't have a negative 0 for it.
It's just 0. Making my way around. So yes, here the tangent's going to be positive, so it is square root of 3 over 3. Right. 1.
Follow a line, you always get to where you want to.
This one.
Should you get lost, though, remember it's y over x.
He's not taking a nap.
Yeah, I was not paying attention to that. Guys, all you have to do is follow the line.
I did work.
No, I'm telling you.
I needed that one. What is?
Once you have this, seriously, cotangent's just going to be the flip of yes. So that is, let me see how it looks. Yes, so in quadrant 1, everything's positive, right? So positive would be sine, cosine, and tangent. Negative's none. Quadrant 2, sine is positive, but cosine and tangent are both negative in quadrant 2. That's just kind of to help you if you need. That's okay. I mean, that's not a requirement of the circle. Sine and cosine are negative in quadrant 3, but tangent is positive because if you divide two negatives. And then in quadrant 4, cosine is positive. Sine and tangent. All right, so look quickly at the rest of the guided notes. Go back to 13. The cotangent. Oh, let's don't do that one. Let's do 15 first. The tangent of 270 is undefined. Literally, go to 270. What's the tangent? Is undefined. Yes, it's gonna be a lot like this. It's the second page of what you already have. No. What's the tangent of 5 pi over 4? The back of the sheet you already did. Look at your circle. You've got 5 pi over 4 on there. It's positive one. 5 pi over 4 is in quadrant 3. Here's 5 pi over 4.
Oh, that makes sense. I just did that angle. That's still should have worked out.
Huh? 10? Where's 10? No. I'm on that, yeah. How about, I don't know which ones I've done now, which one. Go back to 13, cotangent of negative 300. So where is 300 normally? But go backwards that much, right? Square root of 3 over 3. You can do that. You can do that.
Wait. Like, the homework it says use reference angles, and this one says, can we just use the circle for all?
Are we gonna get to use
Like, would that work too?
on our quizzable test?
Say that one more time.
Like, what I'm saying is like, are they asking for the same thing?